All right, so hi, how's it going? We're going to be looking at taking some limits here, okay? And this could have all sorts of different directions you would find in the textbook. It could be called just evaluating limits, okay? Most often in class, I'll just call it take a limit, okay? It could say find the limit algebraically. It could even add the word algebraically, okay, and so forth. So there's various ways of finding a limit, right? And so it turns out this is a pretty easy thing to do, right? So let's start with this one here. When you're asked to take a limit, basically it's saying, look at this expression here. And remember, these are just expressions. These are not equations. There's no equivalencies here. I'm just saying, look, there's a limit. Let x approach 1 in this expression, and then you sit back and see what happens. Okay, so I'm going to say, all right, I'm going to let x approach 1. So I'm going to put a 1 in here and here, and I'm going to see what happens. 1 plus 3 and 1 minus 3. Okay, well, I end up getting, what is that, 4 over 2, or 2. All right, sounds good to me. So as x approaches 1, the value of this approaches 2 is kind of what we're attempting to say here. And in many cases, you're just going to get a number, and you're done with this question, kind of in a way, right? Well, sometimes they'll be a little bit more complicated. For example, here, if I let x equal 3 rather than 1, notice it's the same expression. I let it equal 3 rather than 1, I'm going to see what happens here, okay? And so it's going to be 3 plus 3 over 3 minus 3, which is 6 over 0, which is, undefined. And so we would say that it does not exist. Okay, so when you're trying to find a limit algebraically, and if you get a number over 0, you say, oh, well, this limit doesn't exist. Okay, and if you remember the definition of a limit from before, that either means the left-hand limit or the right-hand limit. Sorry, the left-hand limit and the right-hand limit are not approaching the same number effectively, right? So that's kind of the idea. Now, I went ahead. Now, you don't have to analyze these graphically, but I went ahead and graphed these as well to give us an idea. Whoops. Oh, shoot. How do I do this now? I have to reduce that and make that bigger. There we go. Let me turn off. So the function that we just had is x minus 3 over x plus 3. Oh, no, I think it was the other way around. It's x plus 3 over x minus 3. There we go. So if you recall, our limit when we were approaching 2, which 2 is right here, okay, 2 is right there, was, oh, wait a minute, do I have the right function here? X plus 3 over x minus 3. Oh, no, I didn't approach 2. I approached 1. So the limit as x approaches 1 is 2. Okay? So let me see where that function is. Where is that? It should be here. So it's x plus 3 over x minus 3. And as I approach 1, my limit is, negative 2. Did I forget a negative sign in here? Oh, yes, I did. Huh. Thanks, guys. Thank you, graph. I missed that negative sign because 1 minus 3 is negative 2. So basically what that means is my limit is negative 2. All right? Classic missing of the negative sign mistake. So then why does this limit not exist? So let me go to my graph and approach x equals 3. Okay, so let me go to my graph here. And at x equals 3, which is right here, I'm going to try and approach the graph. Oh, look at this. Well, as we know from last year, this is a graph with an asymptote right at 3. So therefore, the left-hand limit approaches negative infinity and the right-hand limit approaches positive infinity. So that's why the limit doesn't exist right there. Okay? Now we've got a couple of more graphs that we're going to, or a couple of more functions that we'll take a look at. So for example, this one. So again, you're just going to take the number, plug it in, and see what happens. Okay? So here, I'm going to take the number, plug it in, and see what happens. So this is equal to 1 squared minus 6 times 1 plus 5. And this is 1 squared minus 3 times 1 plus 2. And if you look closely, you actually get a 0 on the top because 5 and 1 is a 6. And this negative 6 cancel. 2 and 1 is a 3. And this negative 3, we get a 0 over 0. Huh. Well, guess what? This is called a limit of indeterminate form. Okay? And when you get a limit of indeterminate form, then you don't write that it doesn't exist or that it approaches a specific number. What you got to do is you got to go back to the drawing board, and generally you're going to try and do some algebra. Okay? Do some algebra. Right? So if I take a look at this function here, or this expression here, this is a trinomial over a trinomial. So if I have to do any kind of algebra at all, what comes to mind is, and when I say do some algebra, we have no idea what algebra to do, but if you practice a bit, you start getting some experience, you start to know exactly what algebra you're going to have to do. In this case, this looks like my natural instinct would be to factor the numerator and the denominator, and then you see what happens, right? So if I factor the numerator and I factor the denominator, oh, I don't want to get rid of my limit here. This is still the limit as x approaches 1, okay? Notice here I got rid of the word limit as x approaches 1. Why? Because I made x approach 1. So as soon as you make the x approach 1, you don't write the limit anymore. You don't write this down. But now I'm going backwards and I'm starting over, so I have to start writing this limit again because I can't forget that I'm supposed to be evaluating a limit here. And if I factor this, I'm going to get x negative 1 and a negative 5. This is a negative 1 and a negative 2. Okay? Aha! Well, look at this. Look at what I've got. I've got two factors that cancel. Well, I did some algebra and something happened, so let me keep going. Go ahead here. Well, those are canceled, and now I got x minus 5 over x minus 2. So I'm going to try again. So this is the limit as x approaches 1. Oh no, I don't have to write the limit anymore because I'm actually going to plug the 1 in. So it's going to be 1 minus 5 over 1 minus 2, and I'm going to get 4 over 1, negative both of them, or a 4. So it wasn't 0 over 0. It turns out it was actually 4. And I only discovered that after I sat back and did some algebra. Okay, so take a look here. I've got 3 different cases. I plug the number in, and I get a number. Done. Put a box around it. I plug the number in, and I get a 0 in the denominator and a number on the top. You say it does not exist. I plug the number in, and I get a 0 over 0. Do some algebra. You might say, what kind? I don't know. You're going to have to try something. So then once you do some algebra, your expression will then, things generally simplify, okay? And guess what? Usually the thing that simplifies is the thing that was causing trouble. Because look at what canceled. If I plug a 1 into here and here, I get 1 minus 1, which is 0. and 1 minus 1, which is 0. So the two zeros ended up canceling, okay? And so my limit is 4, okay? And that makes sense. So again, let me go back to our graph here, which is right here, okay? And I think I'm working on this one at the moment, all right? So basically what I did is I said, all right, this is the graph of that function. We just did it. 2x squared minus 6x plus 5, 3x, all this stuff, okay? There's its graph. And we evaluated the limit at 1, which is here. 1 is here. And the solution is 4. Look at that. It's 4, which makes sense because the left-hand limit is 4. The right-hand limit is 4. But if I zoom in right here at 4, I actually get an undefined value, okay? So right here at x equals 1, the function is undefined. But immediately to the left, it's defined. And immediately to the right, it's defined. And both of those values appear to be very close to 4. So we would say, therefore, the limit is 4. Because remember, the limit is concerned not with what is the function at 4, but they're concerned with not what is the value of the function at 1, but what is the value of the function close to 1, both from the left and both from the right. And if those two numbers agree, then we conclude that that is the limit, okay? So here's another example here. So I'm going to plug in a 0. I'll just do this mentally here. If I plug a 0 in, I get 0 plus 4. What's 0 plus 4? 4. Square root of 4. Well, what's the square root of 4? It's 2, okay? Then 2 minus 2. 2 minus 2 is 0. Uh-oh. So I'm getting a 0 in the numerator already. And then I'm getting a 0 in the denominator already. So bang, this is again a limit of an indeterminate form. So what do I have to do? Algebra. So limit as x approaches 0. I'm going to do some algebra. X plus 4 minus 2 and over x. Now, for this particular question, the technique that you want to do is multiply by the conjugate. This is x plus 4 plus 2 over x plus 4 plus 2, okay? And this is called the conjugate of this. And so, effectively, how do I know to do that? Well, because I read it in a book somewhere, and I didn't think of doing this all by myself. So now that I'm showing you, you guys know how to do this. Basically, what's going to effectively happen here is, if you notice, I've got the result of a difference of squares here, okay? And I'm going to end up being able to multiply all this out and get something new. And the new thing that I get will very nicely cancel with my problematic x down here. Because notice this x is the one that's causing the problem, because as I approach 0, that's the one causing the 0 in the denominator, which I don't want to have happen, okay? Which if I can't cancel this x, then I always have a 0 in the denominator, and I would have a undefined or does not exist limit. But if I can effectively cancel this problematic location, then I could change a does not exist limit into an exist limits. Well, I'm not changing it. It's just, it always existed, but I'm discovering that it exists, okay? So anyway, let's multiply this out using FOIL. So I'll multiply this by this. Well, the square root of x plus 4 times the square root of x plus 4 is square root of x plus 4 squared, which is effectively just x plus 4. So I got the limit as x approaches 0 of x plus 4. Now I've got x plus 4 square rooted times 2, okay, which is this, or 2 root of x plus 4. Then I've got a negative 2. I'm going to multiply this into here times the root of x. So minus 2 root of x plus 4. Notice that we just built two things that are going to cancel. And then I've got a negative 2 times a positive 2 for a negative 4. Hey, this is looking awesome. Promising. These guys are canceling. Okay? Very nice. On the bottom, I've got an x still, which is this x. And then I've got this, x plus 4 plus 2. Okay? So remember, I don't want to distribute this x into here right now, because remember, my goal is to cancel this thing. So if I distribute it in, I'm going to have to maybe distribute it back out to cancel it. So I'm going to go ahead and leave it out. But look at this. This 4 and this 4 cancel. So in the end, I actually have the limit as x approaches 0 of x over x, oh gosh, square root of x plus 4 plus 2, whammo, these x's cancel. Okay, so that was the one that gave me the problem. So now that's your key, or your indication that you say, okay, well, now that I've canceled the problematic factor, I'm going to go ahead and try and reevaluate this limit and see what happens. Okay, so reevaluating this limit, let me just write it down. So the limit as x approaches 0 over 1 of x plus 4 square rooted plus 2. Now, I don't want to glaze over this topic here. No, remember, when I cancel an x and an x, and there's nothing left up here, I don't write a 0, because if I leave a 0 up here, then the whole I'm effectively canceling everything. You want to leave a 1 up there, okay? So this x really has a 1 multiplied by it, so it's 1 times x. And that 1 stays there to hold the place, let me know that I still have a numerator there. Now I'm going to put my 0 in, okay? So 0 here. And now that I'm evaluating the limit, I can get rid of the word limit as x approaches 0, and I can actually go ahead and put a 0 in there and see what happens. So I'm going to get 1 over 4, because what's the square root of 4? It's 2. What's 2 plus 2? 4. Bang. I got 1/4. So I was able to discover that my previously thought problematic indeterminate form limit here of 0 over 0, through some algebraic, mischief, I'm able to, do some shenanigans and cancel a bunch of stuff out and manipulate the thing, and such that I was able to discover that the limit is actually 1/4. Okay? And if we want to check this out graphically, look, I actually have the graph here. Here it is. So as I approach 1, no, sorry, what am I approaching? 0. I'm approaching 0. Look at this. As I approach 0, it's tough to get it right on 0 there, but it's at 1/4. You see that? Which makes sense. Can I get actually 0 here? I can't actually. There it is. I got 0. It was tough to get. And notice, again, this is undefined, like in the previous example, right? So right at 0, it's undefined. But just to the left and just to the right of the 0, it is defined, and it's 1/4. So if I zoom in there crazy big, I can kind of see that my limit approaches 1/4. All right. So this next one I'm going to look at the graph first, and we're going to see what our limit is supposed to be. Here's my graph. Where am I approaching? This next one I'm approaching at -3, okay? So I've got the graph, it's ready to go. Where is it? Here it is. X plus, did I type that in right? I did. Okay, perfect. Over here at -3, I should have a limit. Oh, look at that. This graph is undefined at -3, but just to the left of -3, it's -4. And just to the right of -3, it's -4. So I'm expecting when I evaluate this, I'm going to get a 0 over 0, and then I'm going to be able to do some algebraic magic to cancel out the problematic term. And you can see the problematic term. It's right here, because as I approach 3, -3, -3 and +3 cancel to give me that 0 in the denominator. So let's go do that. This is exciting. So again, I'm just going to evaluate this mentally, and I know that I'm going to get a 0 over 0. Watch this. So if I approach -3, I'm going to put it right here. 1 minus 3 is -2. -2 squared is 4. 4 minus 4, bang, that's my 0. And then -3, if I put it into here, -3 minus 3 is 0, and that's my 0. This is an indeterminate form. Do some algebra. Do algebra. Okay? Exclamation point. Okay? Do algebra. So, again, we're going to be like, oh, shoot, what kind of algebra do you want me to do? Well, let's discover what we want to do here. There's a couple of options here I can see. This one we can notice is the difference of squares. So I've got the difference between one thing that's squared and another thing that's squared. If you didn't notice this, what you could do is you could FOIL this out, and you're going to get a trinomial after you simplify it. Then you'll refactor it, and you'll get probably an x plus 3 up in that numerator that ends up canceling. I'm going to use this difference of squares thing. So I'm going to write the limit as x approaches -3. And my first square is going to be x minus, no, I messed that up, sorry. It's 1 plus x minus 2. And then the other one is 1 plus x minus plus 2. Oh gosh, I can't write. 1 plus x plus 2. Again, where is this coming from? I'm taking my difference. I'm square rooting the 4, and I'm putting it here and here. Then I'm square rooting the 1 plus x squared, and I'm putting it here and here. Well, what's the square root of 1 plus x squared? It's 1 plus x, so I'm putting it there and there. And then I'm leaving my x plus 3 on the bottom. Okay? And now I'm going to simplify more. As I'm simplifying, I'm not evaluating the limit, so I'm still writing the limit. And I've got x minus 2 plus 1. What's x minus 2? Plus 1. Well, it looks to be like x minus 1. And what's this? This is x plus 3. Aha! There's our culprit. X plus 3 and x plus 3. Boom. Those cancel, leaving the limit as x approaches a -3 of x minus 1. And now if I go ahead and I evaluate my limit, I'm going to plug in my -3, and I get -3 minus 1, which is -4, which is exactly what I was anticipating, okay, based on our graphical analysis from before. Notice this graph, x minus 1. If you look closely, that's the graph that you get when you cancel everything out. And look at this line. This is the x minus 1 graph right here. But I've graphed the original function. Basically, what that means is for every value of x, the x plus 3 cancels, effectively making it an ineffective thing, right? In the numerator. For example, look, if I just type in a numerator here of x minus 3, plus 3 parentheses. Oh gosh, can't type either. And then x minus 1, and then I go ahead and I stick my x plus 3 there. Look at that. This is the same graph. It's showing up, these two graphs show up at the same location. Okay? Because this and this are the same thing. And then if I just graph the x minus 1 graph, equals x minus 1, it's another graph. All of these three graphs are exactly the same. The difference is this graph doesn't have the undefined location at -4. Look at that. Sorry, -3. -3. It doesn't have the undefined location at x equals -3. Whereas the blue graph has the undefined location, and the red graph also has the undefined location, because in both of these situations, I still have my problematic factor in the denominator. And not until here did I end up having it removed. And it shows up graphically like that, as we talked about in previous situations, okay? So anyway, there's some, questions and techniques on how to evaluate limits algebraically. All right, just a quick recap. Plug the number in. If you get a number, that's the limit. Plug the number in. If you get something over 0, that's the limit. And if you get a 0 over 0, do algebra. What kind of algebra? Well, do a couple of practice questions here and there, and you'll start being able to recognize what type of algebra is going to effectively cause the problematic factor to cancel. Okay. One other thing too, if you plug in a number and you get if you evaluate a limit, the limit as x approaches something, blah, 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 and you get, well, we talked about if you get a number, that's the number. If you get 6 over 0, what happens if you get 0 over 6, for example? A lot of people think that this is an issue, but no, that's not a problem. That just means that the limit itself is a number, and that number is 0. So if you get a number, that's the number. If you get something over 0, it doesn't exist. If you get 0 over a number, the limit is 0, and it exists, and it just actually happens to be 0. All right. Enjoy your day.